For the ninth lesson in this section, we're going to review a little bit and go back and take a look at our rotations, but this time we're going to focus more with them in the coordinate plane and using some of the formulas that we've looked at throughout this chapter. So basically what we have in the first exercise is we have line segment AB whose coordinates are A and B, and they're given up above. What we want to do is draw A prime B prime, the image of AB, after a 90-degree counterclockwise rotation around the origin, and then we're going to state the coordinates of A prime and B prime. So a 90-degree counterclockwise rotation, so what we want to do, if you remember, is we want to physically take our paper and turn it 90 degrees in a counterclockwise direction. And now what we're doing is looking at the segment like it's sitting in the coordinate plane where we want it to end up. So I'm looking at it like this is my x-axis and this is my y-axis. And so if that's the way that my graph is going to end up, point A is over here at negative 5, 1. So I'm just going to turn my paper back around the right way and jot down that that point ended up at negative 5, 1. And if I turn my paper back 90 degrees counterclockwise, point B is at the point 3, 7, both positive. So I'm going to turn my paper back around, and B is going to change to 3, 7. And so now what they want us to do is actually draw in that image. So negative 5, 1 is there, so that's A prime, and 3, 7 is that point, and that's going to be our B prime. So we have the segment drawn. Now we have the segment drawn. It's been rotated 90 degrees counterclockwise around the origin, and we found and stated the coordinates. And so now what they want us to do is use our formulas. They want us to find the length of AB and find the length of A prime, B prime using the distance formula, show your calculations, and then what do you notice about their lengths. So we have the coordinates for A and B, so I'm going to find the distance from A to B. And so remember, that's the formula with the big square root. Underneath the square root, we're going to add the x values. Subtract the x values and then square them. And then subtract the y values in the same order. So if I did 1 minus 7, I have to do 5 minus negative 3, which would be 5 plus 3. And now we can go through and kind of clean that up. 1 minus 7 is going to give us a negative 6. 5 minus 3 is 8, and if we go through and square both of those numbers, negative 6 squared is positive 36, and 8 squared is a positive 64, and when we add those together, we get the square root of 100, which turns out to be 10. All right, so now we're going to do the same thing with A prime and B prime. We want to find the length of that segment. So again, we're going to take the x values and subtract them. So negative 5 minus 3 squared, and then we're going to take the y values and subtract them and square it, and so we end up again with a negative 8 and a negative 6, and when we square both of those we get 64 plus 36, which again turns out to be the square root of 100, which is 10. So what do you notice? Well, what you should notice is that the length of those two segments are the same. The length of AB and the length of A prime, B prime are both 10 units. And so basically when we do a rotation 90 degrees around the origin, the segment will stay the same length. So we can say that distance is preserved when rotating. The distance does not change when you rotate. All right, the second thing that we're going to do, it says in the coordinate plane we will only work with rotations that are integer multiples of 90. So in the next exercise we're going to see an important property that happens when we rotate by 90 degrees. So here we have a segment CD, and they give us the coordinates again and they have it drawn for us. What we want to do is find the image of CD, which is C prime, D prime, after a rotation 180 degrees counterclockwise around the origin, and then we want to state the coordinates of the endpoints. So 180 degrees means we're going to take our paper and turn it completely upside down. And then we're going to jot down where those points end up. So C is at the point 3, -8. So I'm going to turn my paper back around the right way. And C changes to +3, -8. And if I turn my paper completely upside down again, the point D is going to be at -9, -2. So 9 is going to be -9, -2. All right, so now what they want us to do is find the slope of CD and find the slope of C prime D prime, and then what is true about those segments. So I'm just going to take a second and plot my new segment C prime D prime. Okay, so there's my segment C prime D prime. And now what I'm going to do is find the slope of CD, the segment that goes from C to D. So to go from this point to that point, I'm going to rise down 6, and then I'm going to run over 12. So I'm going to rise down 6 and over 12, which reduces down to a -1/2. So I should be able to go down 1 over 2, down 1 over 2, down 1 over 2, and every time I do that I should hit a point on my line, which I do. And now the same thing for the slope of C prime and D prime. So from here to here I'm going to go down 1, 2, 3, 4, 5, 6 units, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So down 6, over 12, and again that reduces to -1/2. So what is true about the segments? Well, if they have the same slope, they are parallel. So CD is parallel to C prime, D prime. All right, on the back, what we're going to do is ask to kind of come up with a rule for some of our transformations. So in exercise 3, it says, which of the following represents a rotation of a point, some point AB, by 90 degrees clockwise around the origin, and it says the use of the grid is encouraged, but it is optional. However, for me, I actually need to work it out and see the picture. So what I'm going to do is just plot some point where I don't have coordinates that are the same, like 3, 2. So my AB is going to be the point 3, 2. And then I need to rotate it 90 degrees clockwise, so that's a -90 degrees. So I'm going to take my paper and I'm going to turn it -90 degrees. And now the point ends up at 2, -3. So my point, 3, 2, changed to 2, -3. So what happens here? Well, I have to change the sign of my A value, and it's going to go in the second place. So my A value, I have to change the sign, and it's going to go in the second place, and my B value is going to come first. So AB is going to change to B, -A. And I got all of that by plotting one point, actually rotating it, and seeing what happened to the coordinate. So now I can go back and look at the choices. And I'm looking for AB is changing to B, -A, which looks like that one right there, which is choice number 4. Okay, so something that we looked at quickly back in our transformations chapter is just a quick reminder that you can rotate around other points that are not the origin, and when you do that, just make that other point look like the origin and still rotate like we've been rotating. So in exercise 4, we have the diagram shows us triangle ABC and it's drawn, and we also have a point D. And what we want to do is draw the image of triangle ABC after a counterclockwise rotation of 90 degrees around point D, and then state the coordinates of the new points. So I'm going to take point D, and I'm going to make it kind of look like a y-axis and an x-axis right there. All right, so I'm basically going to ignore the origin. I'm going to ignore the x-axis and y-axis, and I'm going to rotate around that point right there, looking at it like this is my x and that's my y-axis. So I want to rotate 90 degrees counterclockwise, so that's +90. So I'm going to turn my paper 90 degrees counterclockwise. And then what I have to do is jot down where the points are. So right now, from D to get to A, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8 units. So I'm going to turn my paper back around the right way. And to go from D to A prime, I'm going to go down 8 units. 1, 2, 3, 4, 5, 6, 7, 8. And then that's going to be my A prime. Now I'm going to turn my paper back around the other way again. And let's look at B. To go from D to B, I'm going to go over 1, 2, 3, 4, 5 units, and then down 1, 2, 3, 4, 5, 6. So I'm going to turn my paper around the right way. And from D, I'm going to go over 5 units and down 6. And that point right there is going to be my B prime. And now I'm going to do the same thing for C. Turn my paper back 90 degrees. From D to C, I'm going to go over 1, 2, 3, 4 units and up 1, 2, 3, 4 units. So I turn my paper back around. And from D, I'm going to go over 4 units and up 4 units. And there's my C prime. And so now I have my triangle. Okay, and that triangle has been rotated 90 degrees, positive 90 degrees, or 90 degrees counterclockwise around the origin. And then what it wants us to do is state the new coordinates. Now, from here, we have to go back to our origin. We have to name these points, and you name a point coming from the origin. So at this point, I'm kind of ignoring all that stuff I have over here with D. And A prime, this point right here, from the origin, is going to be over 1, 2, 3, 4 units and down 1, 2, 3, 4, 5. So its coordinates, the coordinates of A prime, are going to be over 4 units and down 5 units. So point B, again from the origin, is going to be B prime, is going to be over 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 3. And then C prime from the origin is going to be over 8 and up 7. Okay, and then it says verify using tracing paper that ABC is congruent to A prime, B prime, C prime. And so basically what you want to do here is just verify that they are the same shape and the same size. And you don't have to do this, but I'll grab some tracing paper quickly. And so what they're looking for here is if you take a piece of tracing paper and you trace over triangle ABC, you should be able to then take your tracing paper and turn it so that it fits completely on top of triangle A prime, B prime, C prime. And then that's how you know that you did your rotation at least correctly because you have the same shape and the same size, so it creates a rigid motion. All right, and then the one on the bottom is multiple choice, so this one I'm going to leave for you. If the point A has coordinates negative 3, 7, and it's rotated 180 degrees clockwise around the point B, which is 2, negative 5, then the image would fall on which of the following points? I would strongly suggest graph paper for this one so that you can plot it out and actually turn your paper and look. But again, the goal here is to figure out which one of those points is the image of A after you rotate it 180 degrees around the point 2, negative 5. So see how you do with that one.